Welcome to the Chapter 4 pre-lecture video. In this chapter, we're going to cover three main topics that are going to come up again and again throughout Statistics 100. We're going to talk about the average, the median, and the standard deviation. Let's start with the two that you're probably the most familiar with, the average and the median. We can think of the average of a list of numbers as the balancing point for that list of numbers, where the weights of each number are weighted according to how large or small it is. And the average is the point at which this list of numbers finds a balancing by weighing each of the numbers equally. So, the balancing point of this list of numbers, the way we're going to find that is we are going to take the sum of the list of numbers and then divide by how many numbers there are on our list. So, let's try it out. To find the average of this list of numbers, the first thing we do is take the sum. So we're going to say 2 plus 8 plus negative 7 plus 15 plus negative 3. And then we are going to divide that by how many numbers are there on the list? 1, 2, 3, 4, 5. We are going to divide that by 5. And we're going to get 15 over 5, which gets us an average of 3. Now, if you weren't convinced that the average and the median are always the same, because what's really the difference between the balancing point and the halfway point? Can't they really be the same? Aren't they trying to measure the same thing? Yes and no. Sometimes they're the same and sometimes they're different. It depends on the list of numbers. The halfway point is the point at which half of the numbers are greater than that median and half of the numbers are below that median. So it's the 50% mark, the halfway point. So to find the halfway point, the first thing we need to do is line the numbers up in order from smallest to largest. So taking a look at this list of numbers, it's not already done so, right? The smallest number on this list is negative 7. It's the furthest that way on the number scale. So the first thing we want to do is rearrange these from smallest to largest. So the smallest number we have is negative 7. The next smallest is negative 3. The next smallest is 2. Then we have 8. And then we have 15. Great. Now we can begin. We have lined them up in order from smallest to greatest. So now to find the median is going to be that halfway point. So in this case we have 5 numbers. And so it's fairly obvious that the halfway point is going to be the third number. But for larger lists where it might not be so obvious, the way I like to think about it is lining up dance partners. So you want to line up the shortest girl with the tallest boy, say. So we're going to line those two up, we're going to line those two up, and who are you left with? Our median. Our median is dead center and has no dance partner. So this works out great for when you have an odd list of numbers, but what do we do if we have an even list of numbers? So let's just get rid of that. And let's just add another number on top. Let's say that we added 18 to the list. Now when we start lining up dance partners, smallest with the biggest, second smallest with the second biggest, third smallest with the third largest, you can see that everybody has a partner. So what's the middle point? So our median is going to lie in the middle of 2 and 8. So how do we find the middle of 2 and 8? We take the average of 2 and 8. So we're going to say that the median of this list is the average of the two center numbers. So we're going to say 2 plus 8 divided by, we're only considering two numbers, so divided by 2. That gets us 10 divided by 2, which is 5. So the median of this list, 5, doesn't even appear on the list. There is no 5, but it's the halfway point of the two center numbers. So for finding that halfway point, just line up your dance partners. If it's an odd list, it'll be a number directly on there. If it's an even list of numbers, then you might end up with a number that's not even listed. So let's just get rid of that 18 and go back to our original, where we said that the median of this list of numbers is that halfway point, that center number, when you line them up in order. So we would say that the median of the list is 2. So the same list of numbers, our average is 3, and our median is 2, proving the point that your average and median are not always the same. Now, how are the median and average going to change as our list of numbers changes? Let's investigate a little bit further. Let's say, for instance, we wanted to determine how the median and average would change if we added 3 to each number on the list. So, let's add 3 to each number on the list, making a brand new list of numbers. So, 2 plus 3 is 5, 8 plus 3 is 11, negative 7 plus 3 is negative 4, 15 plus 3 is 18, negative 3 plus 3 is 0. So here is our brand new list of numbers. So to take the average here, we're just going to do the same thing as before. Add them all up, and then divide by 5, because there are 5 numbers on our list. So we are going to end up getting an average of, when you add 3 to each one, we're going to get an average here of 6. And you can put that in your calculator just to double check, but we're going to get an average of 6. So, let's take a look at what we did here. We had our original average of 3. Then what we did was we added 3 to each number on the list. And our new average, our second average that we got, was 6. So we find that when you add the same number to each individual item on your list, your average is also going to change by that same amount. So you have your original average plus 3 gets you your second average, which was 6. So really, we did a lot of work that we didn't have to do, because this is going to be a rule that we see over and over again. When you change each number by adding or subtracting the same amount to each individual number on the list, your average is also going to be added or subtracted by that same amount. Let's see if the same rule holds up for the median. Let's try and add 3 to each number on the list. So we end up getting this same list of numbers over here. When you add 3 to each individual one. 2 plus 3 is 5, 5 plus 8, 8 plus 3 is 11, negative 7 plus 3 is negative 4, 15 plus 3 is 18, and negative 3 plus 3 is 0. So there's our new list of numbers. So it looks like our median is going to be negative 4. No, right? Because we didn't line them up in order. You have to remember, you can't just say it's going to be the center number on a list where the numbers are all written in a random order. These need to be in chronological, smallest to greatest order. So we need to rewrite this in the proper order, smallest to greatest. So the smallest number we have is negative 4, the second smallest is 0, then we go to 5, then we go to 11, and then we go to 18. Now we can take the median, and the median is going to be the dead center number. So line everybody up, and we find that our median is now 5. So let's step back and take a look at what happened. Our original median was 2, if I remember correctly. So we had a median of 2. Then we went ahead and added 3 to each number on the list. And our result was getting a second median of 5. So the rule holds up. When you change every single number on the list by adding or subtracting the exact same amount, your median is also going to have that amount added or subtracted. So we could save a lot of work here just by saying, all right, we add 3 to every number on the list. Our median was 2. We're going to add 3 to 2 to get a new median of 5. You don't have to start from scratch each time. These rules are going to hold up. Let's think about multiplication or division. Will these rules stand when we multiply or divide? So if we wanted to double each number on the list to see how the average and the median change, we are going to get a brand new list of numbers, aren't we? So let's double each one. So let's do 2 times 2, which is 4. 8 times 2, which is 16. Negative 7 times 2, which is negative 14. 15 times 2 is 30. Negative 3 times 2 is negative 6. So here's our new list of numbers. And then we can go ahead and take the sum and divide by 5. 5 numbers on the list. And this time, we're going to see that our original average was 3. Now, we've multiplied everything by 2, and this comes out to be 6. So our new average, after we've doubled it, average 2, is going to be 6. So the rule holds up here. When you multiply each number on the list by the same amount, the average of that list is also going to be multiplied by that number. The rule also works for division. So when you multiply all of them by the same, your average is going to be multiplied by that same number. Let's see if it works out for the median. Let's double everything over here. So we already did double it over there. So we had 4, 16, negative 14, 30, and negative 6. Now we can take the median, but first we have to rearrange the numbers in the correct order. So the lowest number on the list is negative 14, then we have negative 6, then we have 4, then we have 16, then we have 30. We line up our dance partners, and we see that our center number is 4. So we went from our original median, which was 2. We multiplied every number on the list by 2, and we found that our new median, our second median, after multiplying everything by 2, was 4. So what do you know? The rule works here as well. When you multiply each number on the list by the same amount, your median is also going to be multiplied by that amount. So these are pretty standard rules that are going to help you, especially in an exam situation where time is crucial. You're not going to have to go back to the drawing board for each one. Now let's start looking at some exceptions. What happens if we only change one number on the list? Does any rule apply there? So in this case, let's take 15, the highest number on the list. Let's just take 15 and add 100 to it. So now instead of having 15, we're going to have 115. So we've only changed one number on the list. So our new average is going to be 2 plus 8 plus negative 7 plus 115 plus negative 3. And our new average, after we divide by 5, our average is going to be 23. So we went from our original average of 2, right? Was it 2? Yeah, our average was 3 originally. We went from our original average of 3, we added 100 to one of the numbers, and we ended up with 23. So there's no real pattern there. So when you only change one number on the list, it is back to the drawing board. Let's take a look at the median though. Let's see about adding, instead of having 15, let's make it 115. We added 100 to that number. So now the first step for the median is lining them up in the correct order. So we're going to have the smallest one is negative 7, negative 3, 2, 8, and now 115. So we had our greatest number adding 15 to it. So let's line up the dance partners and see our center number is still 2. So our median did not change because our median was 2 to begin with. And we only changed the largest number by adding more to it. The median stays the same. Well, why is this? And would that rule be the same if I had added 100 to negative 3? Well, the reason behind this is the median is that halfway point. The point where we have 50% of the numbers on the left and we have 50% of the numbers on the right. So when you think about it, I could do anything to these two numbers. I can make them as large as I want. And that median is still going to be 2, because we're still going to have half of the numbers here. It marked that 50% mark. So I could have made this 8,000, and I could have made this 115,000, and my median would still be 2. But what about if I had taken this 115 and instead made it negative 115? Would this rule stay the same? Would the median still be 2? The answer is no, because by making this negative 115, I've taken this number and put it out of order, right? Because it goes from smallest to largest. So this number would have to be shifted over here, which means that our numbers are now rearranged. The order is now rearranged, where we have items that were on the first half of the 50% mark now shifting over to the right, to the second half of the 50% mark. And numbers on the top half moving down to the bottom half. So the rule with the median to remember is if you are changing only one number on the list, and you're changing it in a way so that it only is moving around on one side, on one half, without crossing that median fence, your median is going to stay the same. I could make this negative 17. And just because I'm taking something that was already on the first half of the list and just moving it down further on my list, I'm not crossing over that 2, the median would stay the same. So you could do all the switching and swapping you want as long as you don't cross that median fence. The second you cross that median fence, the number line is shifting, the numbers are rearranging, and now the dance partners are all going to be swapped. So you have to start over and take a look at what your median would be to begin with. So those are some general rules that will help you with your average and your median. Let's dive into standard deviation. So to continue on with the standard deviation, which some of you may or may not have heard of, if you have a scientific background, for instance, standard deviation is used extremely commonly when you're collecting data for science. So what the standard deviation means, it's a measurement of how spread out our data is. Its definition is the typical deviation from average. And what does that mean? What is a deviation? Back in grade school, I remember my second grade teacher calling one of our classmates a deviant, that he had deviant behavior. And what that means is that he was straying from the norm of what was expected in the classroom. He was misbehaving. So we want to know how greatly these numbers are misbehaving, how far they're straying from the average. So we want to think about deviation as how far away are these numbers from the average. So the way that we calculate the standard deviation, I'm sorry to say, it's a little bit more complicated than the average and the median. The way we calculate it is we find the root mean, that is the root mean square. We take the root mean square of our list of numbers. So what that means is we're first going to take the average of our list of numbers. Then we're going to find the deviations. So we're going to see how far these numbers deviate from average, how far they stray from average, by subtracting the average from each number. Then we're going to square our deviations, hence the square. We're going to average those squares, hence the mean. And then we are going to last take the square root, hence the root mean squared. So let's, and also you may be hearing this as the RMS, also referred to as the RMS. So the best way to see how this works is to actually apply it. So let's take that same list of numbers that we were just working on before and calculate our standard deviation. So the first thing that we need to do is we need to take the average of our list. And before we already did that, let's just do it again for old time's sake. We add up all of the numbers on the list, and then we divide by the number, how many numbers there are on our list, and we're going to get our average of 3. So there is our average. Step 1 complete. Step 2, subtract the average from each number on the list. So this is where I like to work vertically now. I like to line the numbers up going down. It's a little bit easier to see the pattern. Okay, so here's my list of numbers, and next I'm going to subtract the average from each. So my average was in pink before, so we're going to subtract 3 all the way down. All right, so negative 7 minus 3 is negative 10. Let's come up with a new color. Negative 10. Negative 3 minus 3 is negative 6. 2 minus 3 is negative 1. 8 minus 3 is 5. And 15 minus 3 is 12. So there, now we have step 2 complete. We have subtract the average. These are our deviations in blue. How far each number is deviating from the average. So the larger the deviation, both in absolute value, positive or negative, means the farther they're straying, which makes sense. 15 is very far from the average because our average was 3. Negative 7 is also very far from the average, so they're going to have large deviations. So step 3 is square each deviation. So now I'm going to square them. Square, 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 all the way down. All right, so negative 10 squared is 100. Negative 6 squared is 36. Negative 1 squared is 1. 5 squared is 25. And 12 squared is 144. Is that right? My times tables were never good. So we have now our squares of each deviation. And you'll notice that each number is positive. Anytime you square something, you're always going to end up with positive numbers. So if you're coming out with negative numbers here, you're not using your parentheses correctly on your calculator. So it's something to be aware of. That's a common mistake we see on exams. Now the last, so we have now squared each deviation. That was in purple. And then lastly, we're down those final steps. Next we have to take the average of the squares. So we are going to add each of these up. Going to add each of these up, and this is where you'll rely on your calculator on the exam. So we're going to take the average of each one. So after we add them up, we see that the average is 306, and there are 5 numbers on the list, so we're going to divide by 5, and that gets us 61.2. So now we have taken the average of our squares. So the average of these squares in purple is 61.2. Now the last step is to take the square root of that average. So the last step is just throw in a little square root bracket on top, and the square root of that is 7.82. And I didn't leave enough room for myself, so I'll write it up here. 7.82. There is our standard deviation. That's the final answer. So, it's kind of a tedious process, especially when your list is getting a little bit longer, but it's a pretty straightforward concept. And the main thing to remember that really carry forward into future lectures is what the standard deviation is measuring, how spread out our data is. So, if we wanted to see this visually, I should have done this before we had gotten into the nitty-gritty of it. But what does this 7.28 mean? That means that each number on the list, the typical deviation of each number on the list is 7.82 from the average. So by how spread out the data is, what I mean by this is, say that we have a nice pretty histogram, a nice normal histogram that goes from 1, 2, 3, 4, 5. There's all our data, all clumped together neatly, and our average would be 3. It would also be our median because it's so beautifully symmetrical. So there's our average right at 3. So the standard deviation is measuring how far in either direction our histogram is deviating. Now you can tell that this one's nice and pretty right next door, right? They're all next door neighbors, but what if my histogram looked like this? The same thing, but just spread out, saying that this was now, negative 1, 1, 3, 5, 7. Now this is much more spread out. So here is my average still at 3, but you can see that the histogram, just in terms of width, it's a wider width, and the numbers are deviating further from the average. Numbers on the list are both a lot larger and a lot smaller than our average. So that's really what the standard deviation is used to measure, how wide our histogram is, how spread out the numbers are on our histogram. So that's going to be very important to understand, especially when we think about concepts like adding a number to each, adding the same number to each item on a list, or multiplying each item on a list by the same number. so you can think about it more visually. And I'm going to leave that for lecture. So I hope that this has been helpful, and good luck on your pre-lecture questions.